Okay, so we've talked about the corresponding angles postulate, the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. And now we're going to just kind of put it all together and take a look at this picture. I've numbered all the angles, and I've just written the different things. So what I want to do is try to find the pairs of corresponding angles and the pairs of alternate interior angles, and then go into what the relationship is. So looking specifically at corresponding angles, we would have angle 1 corresponds with angle what? Well, it's not 2, 3, or 4 because those are all right next to it. It's got to be in the same position above the line. So 1 goes with 5. Now, what's their relationship? We'll come back to that. So we're just going to put 1 goes with 5, and we'll come back to what that means. And then 2 goes with what? 6. Okay. Then we'll do again up here because I don't have room to go underneath. So we got 1 and 2. Now let's go with 4. Angle 4 goes with angle 8. And angle 3 goes with angle 7. Now what's their relationship? So what's happening with these angles? Are they, what's their relationship? Are they congruent? Do they correspond? What's happening? Well, if we look at this, remember this one's the postulate, which means it's supposed to be obvious. 2 and 6, they're both, what kind of angles? Oh yes, they're both acute, and they're both above the line. And if we were to take all this middle gray space out here, if we were just to remove all that space and squish them up, they'd be the same angle. If we could just somehow fold it, right, like maybe there, they'd be the same angle. And so that's why they're congruent, because it's just, they're in that same position. So I'm going to just go ahead and write that relationship. They're all congruent. Because again, they would be in this, if we were able to remove the space, they'd actually be in the same place. So what I want to do now is just get rid of this blue stuff here and move on to the next one. So that is our corresponding angles and the reasons maybe why they're congruent. Now if we look at the alternate interior angle, so again we're looking on the inside. So 4 is an inside angle. Which one alternates? It's got to be on the other side and interior. So and alternates, so go way down here. So it's 4 and 6. So angle 4 and angle 6. Excuse me, jumping ahead. Angle 4 and angle 6. And then my other set is in the inside 3 and 5. So angle 3 and angle 5. Now, why are they congruent? Well, they're both acute, and we know that they're congruent. But why? Now, if we look at what's happening here, we've got the vertical angles thing, and remember that 2 and 6 are corresponding angles, and therefore congruent. And 2 and 4 are vertical angles, and therefore congruent. So then then we can squish that together, transitive property of congruence. Since 2 is congruent to 4 and 2 is congruent to 6, 4 must be congruent to 6. That's that transitive property of congruence. We can just skip that middle step. So that's what's happening there. Again, pretty straightforward. Let me, again, get rid of my blue stuff so I can talk about the next set. And by the way, what I just explained to you is the proof of that. All right, next set, the alternate exterior angle. So on the outside, we've got angle 1, which is an exterior angle. 2 is an exterior angle, but it doesn't alternate all the way down here, so we're at 7. Angle 2 and 7, we know they're congruent. And then angle 1 and 2. 2 and 8, excuse me. And those are congruent. And again, why? Well, 2, 1, and 5 are corresponding angles and congruent. And 5 and 7 are vertical angles and congruent. And then again, the transitive property of congruence, so they must be congruent to each other. So that one again is pretty straightforward and basically the same as the same side as the alternate interior angles. Basically the same idea. So finally we have the same side interior angles, and this is the one that's different and strange. So we are dealing with, for same side interior angles, angle 3, which is on the interior, and on the same side, angle 6. Now you'll notice that I used 1 circle for one and 2 for the other, because these are not congruent. 1 is obtuse, 1 is acute. But 2 is congruent to 6, because they're corresponding angles. And 2 and 3 form a linear pair, and they're therefore supplementary. So we can substitute in and demonstrate that 3 and 6 have to be supplementary. So we've got the measure of angle 3 plus the measure of angle 6 equals 180. I'm going to run out of room, so I'll do it in black up here. We've got the measure of angle 4 plus the measure of angle 5 equals 180. And again, that's our same side interior angles, and the same kind of reasons apply.